Hi, this is Sambath from Hindustan University, working as assistant professor in computer science department. This video is submitted for DigiGuru contest. In this lecture, we are going to see about pipelining concept in computer architecture. Pipelining is a technique of executing the instructions in the computer. There are basically two types of executing the instructions. The one is the sequential execution, the another one is the pipeline execution. Before we are going to see the difference between the two, let's see what is the pipeline execution in the real time, and then we will move on to the pipelining execution in the computer. Now, I think everyone knows about the assembling a car in the manufacturing industry. For example, let's assume there are 4 stages in assembling a car in the car manufacturing industry. This is just for an example. There are 4 stages given over here. The stage 1 is fixing the chassis of the car. The second one is fixing the wheels of the car, then fixing the body of the car, then painting the car. Now imagine the first car enters into the first stage, that is the chassis is fixed. Then it moves on to the second stage. Here wheels are fixed. Then it moves on to the stage 3. Then the body is fixed. It moves on to the stage 4. Here the painting of the car is done. So once it is done, then the second car is entering into the stage 1, where the chassis is fixed, then wheels, then body, then painting is done. So the second car is done. So if you do like this, for example, when the first car moving from stage 1 to stage 2, what happens to this stage? This stage is free. So the equipments which is used in this stage are remaining idle. So to make the effective use of this stage, all the stages, what they are going to do is they are going to send the new car into the stage 1. When this first car moves to the stage 3, then the second car moves to the stage 2, then a new car enters into the stage 1. When the first car moves to the stage 4, then the second car enters into stage 3, the third car enters into stage 2, then a new car enters into stage 1. So at any moment, all the stages in the pipeline are remaining busy. So this is the effective use of the all stages of the pipeline. This technique is actually called pipelining technique. The same concept is going to be implemented in the computer architecture. Now let's see what happens when you are not following the pipelining architecture. Now imagine that each stage takes 1 hour. For example, stage 1 takes 1 hour, stage 2 takes 1 hour, then stage 3 takes 1 hour, then stage 4 takes 1 hour. Now if I follow the normal execution, that is nothing but the sequential execution, each car takes 4 hours for execution. So if I want to assemble 4 cars, 4 into 4, I need 16 hours. Now let's see how much time it requires when I use the pipelining technique. Now imagine the car 1 is entering into the first stage, that is, it will complete within 1 hour. Then when the second car comes in, the car 1 moves to the second stage, then a new car enters into the first stage. This is the second hour. Then at the third hour, car 1 goes to stage 3, car 2 goes to stage 2, then car 3 enters into stage 1. Now at the fourth hour, the car 1 goes to stage 4, the car 2 goes to stage 3, then car 3 goes to stage 2, and a new car 4 will enter into the stage 1. Now imagine we want to manufacture only 4 cars. Let's calculate how much time it requires. At the fifth hour, the car 1 is completed. Car 1 moves out of the stage 4, all 4 stages completed. Now car 2 entered here, stage 4, then car 3 entered into stage 3, then car 4 entered into stage 2. Now at the sixth hour, the car 2 completed, then car 3 entered into stage 4, car 4 entered into stage 3. At the seventh hour, car 3 is completed here, then car 4 entered into stage 4. At the end of the seventh hour, car 4 is completed. So if we use the pipelining technique, we need only 7 hours. But if you follow the sequential technique, we need 16 hours to complete the assembling of the same 4 cars. The same 4 cars can be completed in 7 hours if you use the pipelining execution, and if you are going to use the sequential execution, it takes 16 hours. Now let's correlate this with the execution of the instructions in the pipeline. There are basically 4 stages in executing the instructions in the computer. The stages are fetch, decode, execute, and write back. Fetch, in the first stage, the instructions are fetched. The decode stage, the instructions are analyzed and it finds out what type of instruction it is and what are the operands needed to execute the instruction. The execute stage, the execution of the instruction happens. The write back stage, the results of the instructions will be written back into the memory. Now let's assume each car is an instruction. Now when the first instruction moves to the fetch stage, then it's moving on to the second stage, the decode stage. When the instruction 1 moves to the decode stage, the instruction 2 comes to the fetch stage. When the instruction 1 moves, instruction 2 goes to decode, then instruction 3 goes to fetch. When instruction 1 goes to write back, instruction 2 goes to execute stage, instruction 3 goes to decode stage, and the instruction 4 goes to fetch. Now we will try to calculate the execution in the same manner, execution time in the same manner what we did earlier. Now assume that each instruction takes 1 nanosecond. The first instruction moves to the fetch stage at the first nanosecond, that is I1. At the second nanosecond, the I1 moves to the decode stage. The new instruction I2 comes to the fetch stage. The third nanosecond, I1 goes to execute, I2 comes to decode stage, and I3 comes to fetch stage. At the fourth nanosecond, the I1 goes to write back, I2 goes to execute stage, I3 comes to decode stage, and I4 goes to fetch stage. At the fifth nanosecond, the instruction 1 comes out and instruction 2 goes to the write back stage. Instruction 3 is executing and instruction 4 is in the decode stage. At the 6th nanosecond, the instruction 2 comes out, the instruction 3 goes to the write back stage, and instruction 4 comes to the execution stage. At the 7th nanosecond, the I3 comes out, and at the end of the 7th nanosecond, the I4 gets completed. So totally it takes 7 nanoseconds. If you follow the sequential execution, each instruction takes 4 nanoseconds. So I1 takes 4 nanoseconds, I2 takes 4 nanoseconds, and I3 takes 4, and I4 takes 4. So totally it takes 16 nanoseconds. So if you follow the sequential execution, automatically the time taken will get reduced drastically. So this is the concept of pipelining. Thank you. Thanks for watching.